Hello, welcome to Lecture 2 in my 16 to 18 mathematics series. Hope you enjoyed Lecture 1 on the manipulation of surds. If not, you'll need to know about some of that to perform this to do this lecture. If you're just looking for specific topics, then don't worry. But this does build upon the work from Lecture 1. So, Lecture 2 is rationalising the denominator. And what that basically means is that when we get some numbers, some surds or whatever, they'll look like this. Say like a over root b, okay? Where root b is an irrational number. And we want to turn it into something on the top, usually an irrational number. I don't know, like this, yep. We want the denominator to be rational, okay? Now we can get different cases, but in general you'll have two specific cases of rationalising the denominator. I'm going to go into that now. So let me just drink some water. Okay, so these are the two cases. These are the two cases we can get. The simple form is this. We have a number divided by an irrational number, or a surd. Just a single surd, yeah, like square root of a. So an example could be like 3 over root 5 or something like that, yep. And we want to turn it into a rational number. Well, the method is to multiply by the surd on top and bottom. Now, if you see this number here, root a over root a, this is just equal to 1, isn't it? Any number divided by itself is just 1. So we can times a number by 1 and it doesn't change, which makes this equation true. Now, b times root a is b root a, and obviously root a times root a is equal to a, okay? If you think about this result, times root a is like root a times a, which is a times a is a squared, is square root of a squared, which equals a. Okay, fairly self-explanatory. So what I'm going to do, I'm going to do an example of this, and then we'll come back and look at the second case, the more complicated case. So here's the first case. 5 over root 3, and we want to rationalise the denominator. Well, as we looked back, the rule is, if it's just a single surd like this, we times top and bottom by this number. And the result becomes 5 root 3 over 3, because root 3 times root 3 is just 3, and that's the very simple case. If you get this, you should feel quite happy. The more complicated case is where the denominator is an irrational number formed of two separate numbers. Yep. For example, a plus b root n, okay, which is irrational. Yep. A rational number plus an irrational number is going to be irrational. Yeah. So, how do we deal with this? Well, we have to use a technique known as the difference of two squares. And I'll go into this with you right now. What we have to do is we multiply the top and the bottom of the fraction by a minus b root n. Basically, what we do is whatever this sign is, we switch the sign. And I'm going to show you what happens when we do that, just on the bottom. So with the denominator, we have a plus b root n. Okay, if it was a minus b root n, then we times by a plus b root n. Because it's plus, we switch the sign. This becomes a minus b root n. Now watch what happens when I do this. I'm sure you remember how to expand brackets like this from previous work. A times a is a squared. B root n times a, or plus, is plus a b root n. Next term, a times minus b root n is minus a b root n. Just incidentally, remember when I'm multiplying numbers together, the order doesn't matter. So AB is the same as BA. Yeah. And the final term is plus b root n minus b root n gives me minus b squared root n squared. This is the same as b root n all squared, but I've just written it like this just to simplify things. Well, as you can see here, ab root n and ab root n and minus ab root n will cancel, won't they? These two terms will cancel out. Plus ab root n minus ab root n. Yep. And what you're left with is a squared minus b squared. And what's the square root of n squared? It's just n, which, as you can see, is rational. Yep. This method of switching the sign and multiplying is known as the difference of two squares. Okay, that might come up later. But this is basically the methodology is what you need to know. So let's look at some examples of this. 6 over 2 plus root 3. So the bottom number is the irrational number. And what do we do in this case? Well, like I said, the key concept is switching the sign and multiplying like this. So it was plus, it now becomes a minus. This gives me, leave the top as it is, 6, 2 minus root 3. And obviously we have 2 plus root 3 here, and 2 minus root 3 here. And then we'll leave the numerators the same. We'll just work on the denominator because we're just going to leave this bit. So 6, so I'll just put it in. Why not? We'll put it in. 2 minus root 3. 2 times 2 is 4. We know that these cross-multiplying terms will cancel. Minus 2 root 3 and plus 2 root 3 will cancel. Plus root 3 times minus root 3 will be minus 3. And we see the bottom simplifies to 1. So this actually becomes 6, 2 minus root 3. Technically all over 1, but we'll put it, why not? You wouldn't need to put that in, because dividing by 1 doesn't change anything. So we can see the method here, yep. When we have these two terms, we switch the sign, use the difference of two squares to rationalize the bottom number, because these cross-multiplying terms, 2 root 3 and 2 minus root 3, will cancel out. Good. So I'm going to show you now is the most complicated thing you might get. And it looks like this. 1 plus root 2 over 2 plus root 3. And we have to rationalize the denominator. So again, the method though is exactly the same. 1 plus root 2, 2 plus root 3. We look at the denominator and we switch the sign. So it becomes 2 minus root 3 and 2 minus root 3. So my terms in the brackets are 1 plus root 2, 2 minus root 3, 2 plus root 3, and 2 minus root 3. Yep. You understand this step, I'm sure, by now. Okay. So once we've got to this step, the question is, how do we simplify things? Well, let's simplify the bottom first, because that's the easy one. 2 root 3 and minus 2 root 3 and plus 2 root 3 will cancel out. 2 times 2 is 4. 3 and root 3 is 1. So again, the bottom simplifies to 1. Yep, this is 4, and root 3 times minus root 3 is 3. 4 minus 3 is 1. Okay. So we just have to expand the top now. 1 times 2 is 2. 2 root 2 is 2 root 2. 1 times minus root 3 is minus root 3. And root 2 times minus root 3 is minus root 6. Okay. Now, that's basically the end result, which looks kind of unsatisfying. But that's really as far as we can go. We can simplify the term on the right, the root 6. Root 6 will simplify into you know, root 2, root 3, and there's some tidying up you can do there. But overall, this is fine. The denominator is rationalized. Okay? So, that's the most complicated thing you can get. Alright, so thank you for watching that lecture, guys. I hope that was very useful.